Hello class, and welcome to Math Minutes video lesson number 34. Open up your notebooks to page 12, and we're going to start looking at the second way how to solve a system of equations. Solving a system of equations by substitution. The second method of solving systems of linear equation is to use substitution. One equation is used to solve the other equation by substituting it into the first equation. So in our example, we have two equations. The first one, y equals 2x plus 4. Our second one, x equals y minus 3. Well, we're going to use one of these to solve the other by substituting it inside. So this one here is telling us, our second equation is telling us what x equals. X equals y minus 3. So what that means is, let me rewrite our first one, y equals 2x plus 4. Now, if I substitute this equation in here, well, instead of x, if they're telling me that x equals y minus 3, well, instead of x, I'm going to substitute that in. What is x? Well, x is y minus 3. So now instead of 2x plus 4, I have 2, and this x, I substituted that in. Now, what that did, if you notice, now there aren't any x's in this equation, and I can solve and I can figure out what y is. Y equals, and now I'm going to multiply using the distributive property. 2 times y is 2y, and then 2 times negative 3 is negative 6, and then I'm going to add 4. Now I'm going to combine what I know over here. Negative 6 plus 4 is negative 2. Well, now I want to say, well, I need to get this y over here, so I'm going to subtract 2y from both sides. Remember, there's a 1 in front of that. 1 minus 2 is negative 1. And now when I have a negative y like this, I can just multiply both sides by negative 1. And I can flip my sign, y equals 2. Well, I have found, what's my solution? My solution is going to be a coordinate. So if I can make a note up here, my coordinate, I just figured out what y is, and that's 2. Well, now what I can do is I can take that information and I can, let's give ourselves a little space here. I can put that information and substitute that into one of the equations. And it doesn't matter which one I do. So let's just do the second one. Well, instead of x equals y minus 3, I know that y is now 2. So it's going to be x equals 2 minus 3. Well, what is 2 minus 3 is negative 1. I have found my x coordinate to be negative 1. So my solution where these two lines intersect is at the coordinate negative 1, 2. Okay, I know that probably looks like a lot of steps there, but let's do some practice together. So turn to the next page in your notebooks, and let's do another practice together. So let's take the two equations. 2x plus 3y equals 18. And let's say that y equals x plus 1. Okay, well, it looks like, now I can take this equation and put it in here, or I can take this equation and put it in here. Because this one is already set up for us, y is by itself. If I wanted to use this one, I'd have to rearrange numbers. I don't know, I'd have to do math stuff. The second equation is already set up for us, so we're going to use that one. So instead of 2x plus 3y, it's going to be, I'm going to start up here so we have room. It's going to be 2x plus 3, but instead of y, what is y? Y is x plus 1. So I'm going to put that in parentheses. X plus 1 equals 18. Now I'm going to solve, and what that did, I've eliminated a y variable. So now I'm going to solve for x. I get 2x plus 3 times x is 3x, and distribute that to that plus 1. 3 times 1 is 3, equals 18. Now I'm going to combine like terms. Here I've got 2x and 3x is going to give me 5x plus 3 equals 18. Now I'm going to subtract 3 from both sides. So I get 5x, 18 minus 3 is 15. X equals 3, because I'm going to divide by 5. X equals 3. So now let me just make a note of that. I know that x equals 3. Now I'm going to use that information and put it in one of these equations to solve for y. Well, let's just put it in the simple one. Let's just make life simple. So y equals, instead of x, I know now that x is 3. So y equals 3 plus 1. Therefore, y equals 4. I put that over here. If I were to graph these two lines, this is the point where they intersect, and that's at the point 3, 4. All right, let's take a look at the second one. Let's try 4x plus 2y equals 22, and x equals 2y plus 3. Okay. Well, again, this one looks like it's the easiest one. We're going to put this into this equation because this is already set up for us. So instead of 4x, it's going to be 4. And what is x? X is this equation or expression, 2y plus 3. So I'm going to put that in there. Now I'm going to finish my equation. Plus 2y equals 22. And now I'm simply going to solve for this. 4 times 2 is 8. 4 times a positive 3 is 12. And there's my 2y equals 22. I will combine my like terms. 8 and 2 gives me 10y plus 12 equals 22. Now I'm going to subtract 12 from both sides. 10y, 22 minus 12 is 10. I'm going to divide 10 both sides, so y is 1. Well, let's just make a note of that. My solution, I know my y value is 1. Now what am I going to do? I'm going to take that 1 and I'm going to plug it into an equation. It doesn't matter which one, but let's do the smaller one. If we can still see it with all my little circles and lines, x equals 2y, but now we know y is 1. So we're going to do that, plus 3. What is x? X equals 2 times 1 is 2, plus 3. Therefore, x equals 5. And now I can finish up my coordinate. I know that when I graph these two lines, they're going to intersect. They're going to intersect at the point 5, 1, without even drawing lines or trying to graph something. So again, we're doing the same thing, finding the solution to a system, but we're using a different method. The first way was by drawing the lines and seeing on the graph where they intersect. This one, we're doing it algebraically and solving for the values of x and y. So let's do one last example, practice together. And let's do 3x plus 4y equals 23, and x minus 2y equals 1. Okay, well, which one do I want to use to substitute into the other one? I don't really have one that's set up. In other words, set up meaning I don't have an equation that's just y by itself equals something, or x by itself equals something. So I might have to tweak. I've got to tweak one of these equations to get it into that form. And the easiest one I see to do is the second one. This one here that says x minus 2y equals 1. All I got to do, I just have to move this 2y and get it to the other side, and then I'll know what x is. So let's do that first. So we're going to say that x, and how would I move that? If this is a negative y, I'm going to add 2y. So I'm going to add 2y to both sides, which gives me x equals 2y plus 1. Now I have it set up to substitute this into this equation. So I had to do a little pre-step before I could do my substituting. So now let's write. Now we're ready to solve this. So here we go. 3x But now instead of x, I know what x is. X is now this. So I'm going to put that in here of 2y plus 1. I'm going to finish my equation here. Plus 4y equals 23. And let's solve it. 3 times 2 is 6. 3 times 1 is 3. I'm going to combine my 6 and my 4. That's going to give me 10y. And then here I have my plus 3 equals 23. Let's subtract 3 from both sides because I want to get rid of that. So 23 minus 3 is 20. And then I'm going to divide by 10. 20 divided by 10 is 2. Well, I just figured out what my y value is, so let's make a little note of that over here. I know that y is going to be at 2. Now I'm going to take that information and put it into one of these equations. Let's put it in the easy one, the simple one, right there. So it's going to be x minus 2 instead of y. I now know that y is 2 equals 1. X, what is negative 2 times 2 is a negative 4 equals 1. I'm going to add 4 to both sides. I now know that x is 5, and this coordinate is going to be at 5, 2. So if I graph these two lines, they're going to intersect at 5, 2. Okay, I know that probably seems complicated and a lot of writing, but hopefully you've been introduced to the concept of what it means to use substitution to solve for a system of equations. Again, we'll go over this in class. Good luck. Always email me or text if you have questions, and I will see you soon in class.